Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is 92 truck Mazda B2600, which is complaining about something here. Advanced diagnostics. Spark plug 2 and 4 clean, but have oily, sticky residue. Cylinder 3 felt cross-threaded when removing plug. Seemed to go back in okay. Okay. Well, that could cause compression issues, right? Which could explain misfires. Compression test 160, 180, 160, 180. Okay, so compression is good. All cylinders have spark at the end of the wire. Perfect. Injector circuit at intake connector. Injector 1 and 3, 7 ohms. Injector 2 and 4, 7 ohms. Okay, injectors are fine. With engine running, verified cylinder 2 and 4 not firing. Using oscilloscope, so injector signal not pulling to ground. Verified against injector 1 and 3. Okay, so 2 and 4, injectors 2 and 4 are not firing. Okay, no big deal. What do you guys think it's gonna be? It looks like since 1992, this ECM has not been opened. Judging by the torque of the screws, this has never been opened, and judging by the visual inspection that I'm doing right now, meanwhile, it looks like all the cups are original. And of course there's corrosion. What did you expect? Okay, the damage is not huge for sure. So we have tiny bit of corrosion here. This via is probably done, yeah, most likely. We have green copper or blue copper over here, so we'll check it out, but no big deal. This is probably our most significant damage. Now, oh, and even here, I'm not sure about this. We're gonna see after cleaning. Let's see our two transistors here. So 2 injectors are working. That means we only have a problem on one injection line, which means we have a signal from the distributor. Everything's good there. The sparks are sparking, so everything's fine. So we definitely gonna have 5 volts over here. Oh, it won't boot. We have to bridge the relays. It won't boot without relays. Okay. Some of them are like that. I don't know why, but some of them will turn on without the relay, and some of them won't. So let's just do a quick bridge over here between these two. This one's not long enough. This one. It doesn't have to be a good connection. We are not pushing any power through it. It's just to fool the electronics. Crappy soldering like this will do in there. Okay, so again, we want to see 5 volts here. We have 5 volts, and this is beautiful over 5 volts. Sometimes it's a little lower. This one is beautiful. And these guys, this is low, and this is low, which is good. And let's see, 700 here and 700 here. And that's not good. That is not good because I don't see any issue over here. So let's check the transistors. It's never transistors, but you still have to check, right? It's in reverse. So 0.6 and oh, okay. This almost never happens. 0.27. 0.27 actually is good. 0.6 is a little bit high. Yeah. So could it be a faulty transistor? It's not faulty in a way that it doesn't that it's shorted or anything, but that's not the only way transistors break. And we got 0.6, but that doesn't mean everything yet. This is 0.27, 0.32. Why do we have 0.33 over here now? 0.33 is a little closer. It should be closer to 24, 26. But we have different reading over here and different reading on the transistor. Yeah, look at that. So we got 0.6 over here. But if we go down the trace to the via, we got 0.32. So now if we connect in between here and here, there's your problem. Okay. All right. So that's the problem here. We just don't have. So the reason it's not, which is kind of weird. Oh, right, because the pull-up also doesn't work. Right. So the transistor is just basically floating in the air. That's the problem here. It does, so it doesn't basically have connect. The base is floating because of this one little via over here. This one or this one? Well, we're gonna check them both, but no, it was this one, right? The top transistor. Yeah, right. This should be beeping because this is the trace going directly. So the damage is right here, right over here. That's why no injection. All right, let's get this cap out of here. Let's see if we can just do it quickly as opposed to doing it slow, because the queue keeps growing and growing. And people are asking, where's my board? Well, it's been really cold lately, which is kind of difficult to do VGA work when it's this cold. You know what I mean? So sometimes the boards need to wait for a second for a little better weather. But the weather is definitely picking up. It's gonna be like higher 50s, lower 60s today, and we'll see. February is usually the coldest month around here, so as long as you survive February, it's usually good. But sometimes the weather can play tricks, and you get snow in March. Come on. Okay. Oh, I smell it. It's not significant leak. I've seen a lot worse, but I smell it. And now let's see, what do we have? Yeah, standard. So, let's first let's get some fume extraction because it smells so bad. And let's see what we can. And now the smell of old board and leaked electrolyte. It's undescribable smell. Let's see if we can clean everything here, see if that via is still there. But it looks like it's okay. There's very little damage here, actually. It was just unfortunate that that one via for the injection line got corroded, because other than that, it's not too bad. But that's why if you run this track and it's never been repaired before, right? The ECM has never been rebuilt. You're just waiting for this to happen. There's no way around it. Those caps just absolutely have to leak. That's their life mission. So it's actually, in this case, the customer is lucky that the injector stopped working before there's significant damage to the board. Okay, I still don't see the damage here. Let's check, because now just wicking alone could have resolved the problem, but obviously we're not going to leave it like that. It did not resolve the problem. We still are missing, right? It should be beeping like this, but it's not connected to via, and I don't see the actual damage over here. Well, we could look closer. What do you think? It doesn't even look like it's corroded. It looks like it completely just broke. The trace from the via, it just broke. essentially a cracked trace, not corroded trace. Usually we deal with corroded traces on these. But we got ourselves our first case of just cracked trace unrelated to corrosion. Alright, let's just expose some copper over here. Not too much, we don't need that much. Now after grinding we should be able to see that crack now. But still, I don't see the crack. Well, but we'll see in a second. Yeah, I still don't see the crack. Huh, that's crazy. That is unusual. I would expect to see it now. Let's see. Now after grinding, did the via start working? Yeah, now the via magically started working because we ground through here and those two are touching now. But obviously we can leave it like that. So we're just gonna restore all these. I don't think we're gonna need the wire. Okay, so now if we connect to ground, let's get the better view on it. All right, so this little feller was showing too high. 0.26 correct, and 0.26 correct. Okay, so now we're good. So let's just replace this cap. Now the cleaning, as always, is going to be a nightmare here. Let's just confirm we get all the connections here. We good here, good here, good here. Okay, surprisingly, no significant corrosion. Let's see if the diode is actually making it. Yeah, that's crazy. So pretty much no damage from corrosion. Just broken trace, and that's it. On top of corrosion, yeah. Crazy. Okay, let's seal this. Back in the day, before the times of easy, accessible, PCB services like we have nowadays, we would just draw the board on the copper plate, right? The blank PCB essentially, right? Then put it in the acid, and afterwards, so it doesn't oxidize, you would spend hours just putting solder on the PCB. So that prevents the oxidation, protects the copper and stuff. So that's essentially what we're doing here. And a little bit on the diodes via. But since we know the exact symptoms, we know where to look. So since this was the only problem, which aligns with our observation here, no corrosion damage, no corroded pads, no corroded traces. So there's nothing else wrong. This was the only problem of the ECM. Just two injection lines not work, or one injection line, two injectors not working. Beautiful. Okay, and look at that. Perfectly clean over here. No signs of corrosion. Oh, other than this little guy over here. Let's restore this as well. I mean, again, if this was a problem, we would have known about it. Okay, that looks better. It also prevents any further corrosion, so even if it wasn't a problem, it's not going to be a problem in the future. Yeah, and other than that, everything looks pristine. Okay, so all we have to do is just clean this bad boy and seal it and get it shipped out. I don't know if this one was on the bench fee, or we do have an order number over here. Let's see, because if it's on the bench fee, then we have to, get some more money, essentially. No, it's not on the bench fee, but the customer negotiated better price. Good. Don't be afraid to ask, guys. If you can't swing $200 for this, just make me an offer. Usually they are accepted. So this one we're doing for $180. All right, let's clean it, seal it, ship it back. And the next one. Oh, and of course I need to put the new cap over here. So we'll do that as well. And we shall be done. But I'm not going to be boring you with that because it takes about an hour, hour and a half to clean it, because you have to work with the toothbrush. I have those new toothbrushes now, anti-static, ESD safe, whatever. I don't know if that's even true, but so essentially, you know, you soak it and then you brush it. And sometimes you have to work with tweezers, you know, it takes a while to clean it from old conformal coating. So I'm not going to bore you with that. Hopefully you found this useful. It's another ECM saved. Thank you guys very much for watching. I do appreciate you. And I shall see you guys in the next one.